So good afternoon, everyone. So it's right after lunch. Really good time to learn our databases. So it's my first time in Taiwan. It's my second time out of my own country. So I'm really happy to be here. So my name is Harisankar, hard to pronounce. In Twitter, Facebook, GitHub, everywhere I'm CoderHS. And I write Ruby code for a living. I work at Red Panthers. We're a small dev shop, 16 people in Cochin. And I'm from the city of Kochi. It's in a state called Kerala in India. And we have a lot of elephants. I mean, we have lots. Namaskar. So that's how we greet in Malayalam. That's a language spoken in my state. So there's a fun fact for you. There's 22 official languages in India. There's 1,653 spoken languages in India, and over 50,000 dialects. And I know 3 of them. So I'm from a huge and diverse country. So coming to Taiwan, I feel like I just went to another part of my own country whose language I do not know. So I'm kind of feeling right in. So I bought some chips from Kerala. So after my talk, I might share with you. So come talk to me. Okay, so let's start. So I'm talking about Rails, okay? Our web application development. So we have our tech stack. It's like the Team Avengers. You know, they're good, really good together. Really bad movies when you break them up. But, so let's see. Ruby is, of course, Captain America. Rails is Iron Man. Okay? And our database is the Hulk. The Hulk can smash anything. Okay? But the problem is, you know, we have this super strong guy, and we use him to carry our suitcase. Okay, he's just using it, you know, to carry around our data as a filing cabinet, when our database can do much, much more than that. So my talk is about this. How we are going to offload a couple of things that Rails is doing right now to a database so that we can improve our application's performance without actually need to buy new hardware or introducing something new to our system. Okay? Because we have a Hulk and we should use it. So today I'm going to talk about query planner, indexing, materialized views, and generating JSON. Okay, it's kind of database specific, but all this concept that I'm talking about you can find in any database there is. Though my database I'm explaining about would be PostgreSQL. Any PostgreSQL users? I hope. Oh, that's really good. MySQL? Really bad. So, the query planner, it's the heart or the brain of any database. So we have this SQL query that we write, or we don't write. Anyone who works with Rails prefer working with active records itself rather than writing SQL. Well, I agree with you guys. Because the reason why I started using Rails, or I moved from PHP to Ruby, is because I don't have to write queries anymore. You know, we could just do user.all and I got everything. Okay? And I was really happy. That's it. All my projects, I'm going to stop PHP. I'm going to start doing Rails. But 6-7 years down the line, you see more and you realize stuff that you didn't realize when you started out. So one thing about SQL is like different from when we write Ruby, is that in SQL we only talk about data or what our data should be like. Like I say that I need select ID name. we never tell the database how to get the name. We don't tell them which algorithm to use or which, I don't know, what kind of optimizations need to be done. We just tell the database, we just order him to bring me my name and ID or an email. Okay? So there should be some part of your system that does this for you. Because we know that when we write Ruby code, we care about the complexity, the time, the space complexity, everything. But when it comes to database, a lot of people, beginners more or less, ignore the fact that database is another program, another piece of software that needs to be told how you get the stuff. So where is the decisions being made? So that's what Query Planner is all about. It's the brain of our database. We need to understand how it works if we want to improve its performance, right? We need to know how the performance is presently calculated by your system if you want to improve it. So a database, when you run a query, creates a plan, an action plan for you. The plan is basically the cost of running your query. So there might be multiple paths for the database to move. So it calculates the paths for everything and then choose the least path. Now the thing about the query planner is that it assumes the plan that it has is the best plan there is. Okay, so that's a problem. Because if the database, there might be better plans, but for that it requires a human to input it, to make it pick the right one. So how can a DB handle all the scenarios? The truth is it can't. Okay, we use a DB for a lot of different purposes. Like some people just to store student records. Some people might be using it to log transactions. In my case, I've used it to a back-end logging for IoT devices. All my devices talk to my database, and our database has to process everything. And it gets displayed on the dashboard. So every programmer's web application is different. So we need to nudge it. We need to optimize it. So to optimize it, we need to see what the query planner sees. And ActiveRecord has a method that gives you this plan. Okay, it's a .explain method, and this is basically it. So if you've done an SQL query with an explain, it gives you the cost. And it says like the number of rows it returns and everything. So at the top, you can see that I'm looking at user with an ID, which is indexed. Whereas in the lower part, I'm looking for another thing which is not indexed. Okay? So as you can see, the cost of the searching for something which is not indexed is higher than searching for something which is indexed. So that's where we're going to start with. A basic thing that everyone knows, that's indexing. So let's see how we're going to do that. And I can assure you I've done all this in production, so don't feel scared to do any of this. So let's index. Let's index everything. That's the simplest answer, you see, because you just saw a plan that made your queries run 4 times faster. Why just indexing? Okay, let's not index everything. Because indexes are like special lookup tables that take space in your hard disk, okay? It's being used by your database to search for data. So if an index doesn't exist, what the system does, it goes through everything, one after the other. It's a sequential search, that's it. It goes through everything, it finds the guy for you, okay? If not, if there's an index, which is like an ordered pair, like A, B, C, D, everything will be ordered so that it goes up to B, you search for Benny, and Benny is not there, then that's it. You don't have to go further. So, and another thing is, as I told you, the database is a really smart thing. Like even if you have database, your system will ignore it. If the system feels like searching the database, searching by an index is more costly. So a case for this is like if you have a column with just 3 values and you index it, and you have 1 million records, Okay, database will be much faster if it just sequentially search through everything, because there are only 3 values. So what all should we index? That's the question. So a primary key, we should index it. A foreign key, we should index it. All columns that you're planning to search, let's say your reports, your name, age, okay, anything that you feel like you're going to use it again and again, or it's not just a one-time thing, you need to index it. The keys you use to join tables, like sometimes you don't just use the foreign keys to join tables. Sometimes you join through age, ranks, or name. Okay, if you plan to do that, then index it. The date column, index it. If you plan to create a lot of sales reports with a column mentioning the day the sale had happened, feel free to index it. The type column in polymorphism, you have in Rails, right? You define type, index it. And partial index to scopes. So partial indexes are partial indexes, in which you don't index the entire thing, only then you index the part that satisfy your conditions, which are your scopes basically. So your Rails scopes will start to run faster if you, let's say, a condition in which if there is a sold at, if sold at is null, that means it's not sold. Okay, you have a scope for it. If you have partial index for it, it also runs faster. Do not index a table which has lots of reads and write. As I told you, I'm working on an application. We have a lot of IoT devices that's piping in data like a couple of gigabytes every 10 minutes. And if you go and index that thing, it's just going to like add an overhead for your database. Because every time you insert something, it indexes it. Okay, it happens during the time you insert. It's not like a background process that does after some time. It's real time. So if you have a lot of read-write, then do not index it. Do not index if you know that thing is going to be really small. Okay, you have a settings table, and it's always going to have like 10 rows. Don't waste time indexing it. And do not index something if you know the value is going to change every single second, or every time you use it. For example, do not index created at or updated at. Okay, Rails will, index created at, it's fine, but do not index updated at, because every time you update it, it changes. So that's about indexing. So indexing basically gives you easy access to all your data. So when you do reports, you have to index. And with the newer data types like JSON and hash, you can index the individual parts of the JSON as well. All the keys, the values, everything can be indexed. Okay, so make good use of your index. If you feel like if you think that indexing is not for you, then I'll suggest you just do an explain on your query and see how fast or how slow your system is right now. And next, I'm going to talk about materialized views. And this, I think personally, is one of the greatest thing with the database. Okay, everyone who has worked in Rails knows the MVC, where the view part, what it actually does is combine data from a lot of different models and display it for us, right? So that makes our life easier. So the database has something similar in which it combines a data from multiple tables and make it look like a single table, a pseudo table. Of course, you do that with joins. Okay, you join 2 tables, you create a new table, right? My question is, like, you have to do the join every single time. But if you tell your database that I'm joining information from my employee record, I'm joining information from the user table, I'm joining information from the attendance table, and I'm going to use that to create a new information. Okay, so you're going to do this every time. If you make it a view, you just need to access the view every time. So why should we use it? Because it makes our life so much easier. Okay, you have this view defined. Every time you want to do something, you can do it on the view. But it's like you have from your companies, you have a list of all the people, employees of the companies, and it has a row. So instead of doing select ID, name, email from companies where role equals managers, okay, you can create a view in which is called company managers, and you just need to do that select from company managers. Okay. The thing about this, the schema lives in the RAM. Okay, it's not written everywhere. It's a pseudo table. It doesn't exist. Okay, so every time what you're seeing is select star from company managers, but what actually happens is select ID, name, and email from company where role equals managers. So it's actually using the existing tables itself. Now, materialized views is like the next evolution, okay, or the next iteration of the view, in which you don't just store the schema, you actually create a table in which you store the real data in the hard disk. Okay, it's like a cache for your database. So it was first introduced by Oracle. It's found in PostgreSQL, Microsoft SQL, IBM DB2. It's not there in MySQL, I'm sorry. But you can implement the same thing as you can create your own temporary tables if you want and just implement the same concept, or there are open source extensions for it, so you can use it. But how can I use it in Ruby? That's a question, right? Okay, we are not here to talk about SQL. So thanks to active records, it's easy to access such pseudo tables. So you need to write a bit of SQL to create a materialized view. Okay, you need to run the SQL as a migration, in which you ask, let's say, all-time sales. Here in my example, I have the all-time sales records. So I have a table with all the sales record of a company. So what I'm going to do is I'm going to create a new table, a new view in which I have the sum of all the sales happen in a day, which is a common scenario for most companies. They want the information, which is what we usually give to the charts and data tables, everything. So instead of every time you're doing this, running the query and getting the data and then sending it to your front end, we just created a table, which is like a pseudo table, which has all the data, and you're sending it. Just in short, if you ask in a collection to pick 3 pebbles, red, blue, and green, it's going to be hard because you need to get red, blue, and green. But if you just say, just give me the entire basket, it's faster. So that's what's happening here. And once you're done with the SQL and the table is created, we can create our own model file, okay? And we can define the name of the table. Okay, we just self.table name and give the table the name of the view that we just created. That's it. You can just access your table, the new view as if it's a regular model in your system. And I place all my view files under the model folder, following the same structure as the Rails app models views. And now you can do select name, you get all the names. You need to search, you can do it. And another thing, you can index this, okay? Because we just create a new table, and if it's going back to the same old thing, it's not right. So we can index this new table because it's an existing table in the system. But another thing that you have to note here is that this table is based on data from multiple tables. So we can't update this because the information comes from multiple places. If we update this and it's not updated in the original place, it kind of spoils the entire purpose of your database, which is like a central repo storage of all the information. So you can't have wrong information at one table and another information at another table. So it's a read-only table. So you need to define it as read-only is true. If not, Active Record will try to update it and it will just create an exception. Okay, and if you place it true, it won't let you do it. And another thing that's a bit frustrating about this is that it doesn't have real-time information. Okay, so you have this new sales happening every single day. Across the country, you have this point-of-sale machines having data, but your system cannot update it because it's so the purpose of it. You need to refresh it. You need to get the latest data. So you need to do a manual refresh, which is another SQL query. But before PostgreSQL 9.4, you couldn't do this concurrently. Because when you try to refresh, new data might be coming in, right? Or someone might be trying to access the existing table, the MapView table that we created. So we need to, PostgreSQL, what they did is they blocked it. Any new queries going to that model, it'll be in a queue, it's blocked. Okay, but since PostgreSQL 9.4, it can run concurrently, so that when people try to access, they get the old data, and when the new data comes in, they get the new data. This is a common problem when we're using with views. The first, last, and find will not work because it runs on the primary key. In the pseudo table, we don't have one. Okay, even though if we call the ID from a table, it's not the primary key of the new table unless you tell this is the primary key of the new table. Okay, so in actuarial model, we just need to mention which is your primary key, which you can add it in Ruby itself. And that's my benchmark, and that's a real benchmark. Okay, my query time from 976 milliseconds became 2.3 milliseconds. So what's the takeaway from using MapView? It's faster to fetch data. It captures commonly used joins and filters, pushes data-intensive processing from Ruby to the database. Okay, allows fast and live filtering of complex associations. Like you have this huge SQL query there on which you're trying to filter. Every time you, let's say, sort by date, sort by name, you're running this over and over again. Okay, so instead of doing that, if you have a view, which means that you don't have to do it again, and makes your system much faster. And you can index the various fields in the table, which is a huge advantage. But there are pain points as well. Like working with all this, there are huge pain points like this. We need to write SQL. Okay, that's one thing that you cannot avoid because there's not much Ruby support for it yet, but to all the Ruby developers here, that's a huge chance for you to create some open source projects. Okay, you can there are companies that create extensions, which helps you do all this thing in Ruby, but it's still not 100%, so you can do it. You can try to contribute to active records. We'll be using more RAM because everything resides in the memory, but it's not huge, but still we are going to use it. And yes, the same data will be there. When we go to materialized view, we are going to store it in the data, the hard disk as well. So as you can see, it takes more space. So when you're working with 1 million rows, it's going to be a huge problem. Okay, because you just have another table with another 1 million rows. So you need that space. And you can't have live data. But there is a workaround for this, because you know the concept, right? You can implement it on your own. Okay, you just create a temporary table of your own that has this table, and instead of creating a view, you just make a record of the migrations or the changes so that you fix it. Okay, you can do it, though I won't recommend it. Okay, we have a database, let's use it. Now this is something that's really important for every modern day web applications. Okay, JSON. The days of simple HTML and plain JavaScript based Ajax is over. Okay, even this RubyConf, we have talks in React, Redux and everything. Why? Because the modern day web application, you need a really good JavaScript framework on the front end to take care of everything. And the JSON is the glue that connects your front end and your back end. So you can, it's natural for finding more database supporting JSON nowadays, and also storing JSON. So let's say we are going to convert a single row to JSON, like the to_JSON in your Ruby code. In SQL, we write that select row to JSON users from users where ID equals 1. You have to write SQL here, and you get the entire row of your database as a JSON, and that's it. You just send it. You send the response directly to your friend end. You just make Rails take the JSON that your PostgreSQL database generated, and you just give it to your friend end, and that's it. Else, before you get the data, a lot of active record objects are created. Okay, you have 100 users, you have 100 objects created, and all the 100 objects is converted to JSON. Okay, which is no longer required because this memory saved is like performance improved. For practical cases, we don't send the entire JSON. Okay, we can't send the entire rows to the front end. Okay, there might be information that that might be what you say it's important, and also a lot of garbage data. We don't need all these information. So we just do a proper SQL query where we take the name, so ID, and email, and you just send it. Also, it can get complex and complex. Now, the problem here is you get more web rows, you get more code to be written, which, to be honest, I don't like it. As Matt said, I'm a lazy programmer. Okay, we are all lazy programmers, so writing more code is not for us. But it's important that we should know that this is what's happening on the back end. This is what's going to happen. This is what's getting created. So in this SQL query, what I did is like, you're getting my name, my email and ID, as well as all the projects that I created. So what we're doing here is like preloading of data. Before, like, if you want like more projects, when you do in Rails, you are linking to more project objects. As you link to more project objects, that's more memory. And every time you connect to that project, you need to fire another SQL query. Okay? But instead of that, in a single SQL query, we are getting all the data that we need, and we send it to our applications front end. And the latest version of PostgreSQL, not latest, but later version of PostgreSQL, they have this simple method in which you can just create some custom JSON you want. Okay, let's say you just want to create a JSON that's not even part of your database. Okay, in which case you can just select JSON build object. Just pass in the keys, you pass in the values, and that's it. You get your JSON. So where is Ruby? Okay, this is a Ruby conference, man. Why are you talking about databases? So as I told you, like, there's no official support, like nodes of gems are coming up. So this is a gem that I use, SURUS. I find it really hard to pronounce. There's your Ruby. Okay, user.findJSON1 gives you the JSON of the user with ID 1, which makes all that I wrote here stupid. But you need to understand how it works. Only then we can extend it. And of course, if you want to include more information, object preloading happens there, like the user with all the posts, all the admins and everything. So it's like active record objects itself. We're just adding all this extra functions. But it kind of breaks when it goes to complex joins. Like for example, relation through. Okay, you have, if both the records are named the same, it's fine. But if you're aliasing it, it breaks. Okay, so if you guys want to contribute to open source, feel free to send a pull request. So in the end, like if a code requires more complex JS, then we end up writing more SQL. So we can't avoid it. But what's one thing that I did, because I don't like writing that much of SQL, so I created a materialized view for it and then converted that view to JSON. So we have something complicated like this. You make it a view, and you make that view into a JSON. And the benchmarks that I did, like I was able to reduce the time for a JSON request that I made to my server from 2 seconds to 200 milliseconds. But the thing is, like, you can't like properly benchmark this because everything depends on the users, the type of code that you do, the way you request data. In my case, I was getting the data of all time. I mean, I had the information for like 20 years, and which we were like doing, we did a lot of good SQL, and we did this with SQL itself, and gave that 2 seconds, and when we changed to MapView, it became 200 milliseconds. And of course, I didn't use any caching, so if you guys do cache, then do the math. It's really fast. Some online benchmarks that I found is that for simple query, the speed is not much. When you search for something, like the first one is just plain Ruby, the second one uses Splunk, and the third one is using PostgreSQL. So for simple queries, it's not make much a difference. So if you're planning to do just user find JSON, it's not going to make much difference. But for complicated ones, the speed difference, as you can see, is like 8 times. It's because, to be simple, PostgreSQL is using more assembly or machine code to do all this, whereas in Ruby we are using dynamic interpreters. Of course, there are libraries in Ruby that uses C bindings to create JSON, which will also be faster, but not as fast. I don't have any benchmarks for me yet, but if you want to see the code that created all this benchmark, then you have the URL there. And my last part, okay, I'm not going to bore you about database anymore, and we can go to questions. So this is a synchronous commit. So PostgreSQL or many databases, there is sacrifices speed for durability and reliability, which means PostgreSQL is known for slow writes and faster reads. If it has slow writes because it waits for the system to confirm that it has been written. Okay, you send a request, it's like waiting for that 200 to proceed to the next one. So, but you can disable it. Okay, when you disable it, the thing is, it sends the data, it knows that the transaction has been recorded, and it moves on to the next transaction. It doesn't wait for the hardest to confirm whether the transaction was completed or not. Here also we have the Ruby code to make sure of that. So inside a transaction, you can set the synchronous commit to false, which means the system will not wait for confirmation whether the thing is completed or not. It will proceed to the next one. But the problem is, if your hard disk happens to crash all of a sudden, the data is gone. It's not like it will take like a long time for it to confirm to write, but all of a sudden that's doing, while you're doing this asynchronous commit and the system crash, you might lose like all the records for, let's say, last 5-10 seconds perhaps. Okay. In some cases it's really bad. Like a banking software, 5 seconds could be millions. But for a logging application or IoT devices, 5 seconds won't make much of a difference because you're sending the data again. Or you can just ask the device to send the data at another time. So it gives you that flexibility. So it's up to you. To summarize, index data so that we don't have to scan the whole database. Simplify the way you fetch data from the DB using views. Move complicated JSON generation to the database. And disable synchronous commit when you feel like it won't cause a problem. So as a conclusion, know your tech stack. Okay, we work in Ruby, but Ruby is not the only thing that's part of our system. We should have control over all the moving parts. You might be using Redis, databases, caching, everything. You should have a good control over them. Try to bring out the best with your tech stack before throwing more money at it. Okay. And SQL has been around for like 40 years, and it's planning to stay for a while, so there's no running away from it. And also, like, there is no golden rule for this, because what might have worked here might not work for your project. You might have a special case, so there's no golden rule, so we always have to keep on looking. I have blogged about all this in more details. You can read about it, all the information from where I gathered everything, all my benchmarks, you can find it here. So if you want in more details about any particular token, just visit there. Questions?
Does anyone have any questions? I can take one, since we ran out of time. Okay, if you are too shy to ask any questions, okay, you can come to Harisankar afterward. Thank you.